Hey, Dr. B.
Hi.
How are you?
Good. How are you?
I'm all right.
I'm so excited.
I heard you had a math problem.
I do. We have a math problem. So in Cambridge, what we do is we apply math a lot to different chemistry and fun science things. But my students actually struggle just a little bit with dimensional analysis, or you called it or something else earlier, conversion factors or something.
Yeah.
And so we need to just translate it and bring it from a math perspective. So please help me.
And I think stoichiometry problems are more broad. It's not always converting from one kind of unit to another.
Right.
But in my pre-calculus classes, that's exactly what we're doing. Like converting from radians to degrees, and you're sitting here like, oh my gosh, is it pi over 180 or 180 over pi? That's hard.
Mm-hmm.
But there's like an established technique that works.
Okay.
This railroad tracks method. It's amazing. And so I want to talk in depth about how that technique works and how you can use it to get your awesome math problems done perfectly every single time. So we're starting with a really basic problem here. How many inches are in 9 feet?
Okay.
And I think that a lot of us know that what you do is you take 9 times 12 and you get 108 inches, right? And you're like, oh, I'm done, moving on with my life. But let's take a pause, take a step back, and like think about this a little more formally. Like, how did we know that we had to multiply by 12? Right?
Just feels so instinctual now.
Yeah,
So.
you're like 12 inches in a foot. What? But let's do this in a more formal way, because that's what's going to translate to the harder problems, okay? So you say to yourself, all right, I know that 12 inches is literally equal to 1 foot. Like, that is a math equation that we have. 12 inches equals 1 foot. And so what this means is when you are converting between inches and feet, you get to pick between one of these two fractions, 12 over 1 or 1 over 12. And I think a really important step here is that you write them both out, and that you have like the units sitting there next to the numbers.
Smart.
Because that's what gives you the clue on which one you're supposed to use. So actually, you taught me this. Railroad tracks. So you set up your railroad tracks, and then you write your original like number there. You have your 9 feet, and it's sitting there on top. And then you ask yourself, am I supposed to use this fraction or this fraction? Well, if you want the feet to die, if you want that unit to go away, feet needs to be on the bottom.
Yes.
And so that indicates that we are supposed to use this conversion factor. I don't know, that's what I call it. You use that one. And so that's how you know that feet, those cross.
Feet, cross.
And what you get is 9 times 12. See, the 12 is on top. That tells you to multiply, not divide. And so the inches survives, and that's the answer.
Love it.
Right.
Yes.
So let's kick it up a notch.
All right. Here we go.
All right, so this is America, as you know, and we use miles. Most of the world does not. And so how many miles are in 8 kilometers? So something that I've been a runner for many years, right? I did cross country in high school. I ran a lot of half marathons and marathons. And something that I noticed is when you sign up for a race, even in the United States, what is it that everyone signs up for?
It's not miles. It's like a
5K.
5K.
Right? You sign up for a 5K or a 10K. And so I think that's very strange. That, like, that's an exception to the American rule of, like, distance. Anyway, so let's say you're signing up for an 8K race or something, and you want to know, like, how many miles is that? How long does it feel to me?
It's the first thing I would do.
How many miles? Because 8K means nothing. Okay, so here's the thing. As a runner, I've signed up for a lot of 5Ks, and so I've just memorized. Like, I know this in my heart that 5 kilometers is about 3.1 miles.
Okay.
I've been doing this for so many years. That's what I know.
Okay.
In fact, we're gonna ask these 3 major questions to solve this problem. What do we have? What do we want? And what do we know?
Okay.
Okay.
Have,
so
want, know.
Have, want, know. We have kilometers. We want miles. And what I was saying was, I know that 3.1 miles is about the same as 5 kilometers.
Got it.
In fact, honestly, day to day, I often forget what 1 mile is equivalent to. I don't know, somehow that just doesn't impact my life as much, but I remember that 5K is about 3.1 miles. And so the point of this example is, you don't have to know what 1 mile is. You don't have to know what 1 kilometer is. You can know any equivalence and make conversion factors out of that.
See, that's nice. We don't teach that. That's nice.
It's pretty slick. And so what I'm saying is, to solve this problem, these are the conversion factors that you can pick from. It's just one way of many to do this problem. And so once again, you set up your railroad tracks. The thing you have goes right here. You have your 8 kilometers. You know you want the kilometers to go away, which means kilometers goes on the bottom. And so that is the conversion factor that we should choose.
Okay.
You get out your calculator and tap, 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 and you get, it's about 5 miles.
Got it.
So that's a 5-mile race I would be signing up for.
Oh, that's pretty long. So question, what about my track people? Could you do this if you were in
Your
track?
sprinters? I think that 5K is just abominable.
That sounds
It's
terrible.
totally unacceptable. Okay, so there is a possibility. There's like I said, there's many different ways to do all of these problems, okay? So let's say that you're a sprinter.
That
Now,
would be me.
right? Standard high school track, a mile is about 4 laps around. Coach makes you run 4 laps. That's a mile. And then I also know that a lap is about 400 meters. For some reason, the track is in metric too. I don't understand it, but that's life. Okay, so you have 1 lap is 400 meters. And finally, I know that 1,000 meters is a kilometer because that's how kilo works, right? That's metric. So I've got all of these things that I know, and each one of these things results in a pair of conversion factors that I could use.
Nice.
And so when I'm buried in a really hard math or chemistry problem, I go off to the side and I just start writing all of this junk out. And you're only going to use about half of it, or maybe not even. But that's the point of scratch work, is it organizes your thoughts in a visual way, and it lets you pick exactly what you need to solve the problem.
I love that.
Right? So, again, ginormous railroad tracks, because this is going to take a bit.
Yep.
And you got your 8 kilometers. Kilometers needs to die. We need to kill it with fire. So, I'm looking down here, and I need to choose one of these for my railroad tracks, and if kilometers is going to die, it's got to be that guy.
Got to be on the bottom.
Got to be on the bottom.
Okay.
Kilometers on the bottom. So, that's what I'm going to have.
Okay.
Well, meters was not what I wanted. I wanted miles. So meters needs to die. So now I need to choose from one of these two. And again, I'm going to choose the one with meters on the bottom. And so that's what I'm going to have.
Perfect.
But I also didn't want laps. Laps is a really weird informal unit. We just made that up. So we need laps to die. And so we're going to choose from one of the top 2 units. A whole bunch of these units are going to cancel. You tap, tap, tap with your calculator, and you get that it's about 5 miles.
Beautiful. See, that's the way I would have done that in my head, personally. I would
With
have
all
done
those
that
steps,
approach.
really.
Yeah, I would have. The other way around is not just
Because, trips around the track is what makes sense to you, right? So there's a lot of flexibility in how you do these, depending on what
clicks, how
your life experience
Yeah,
is.
exactly.
Yeah.
Oh, I love that. Okay, so now, for my Cambridge students, or any students, you're recommending that we could come up with these conversions, put them on the side, and then just walk through this. What do I have? What do I want? What do I know?
Yeah.
Use these little things. I love that. That helps.
I really do. I recommend, until you're absolutely beast mode and you have all of this memorized, I think that it's very important to write down these equations followed by these fractions.
Okay, so equations first, then the fractions.
Right.
I
It
like
lets
that.
you really visualize putting the fractions in exactly the right place, the way that they need to be.
It's awesome.
Yeah.
I love it. Do you have another one? Maybe a hard one?
I do. Yeah. I drive a Honda Civic.
Oh, it's beautiful.
Very fuel efficient. It's not even a hybrid. 32 miles to the gallon.
It's really nice.
I love my little car.
Mm-hmm.
What if, I don't know, for some reason I shipped my car to Japan. I decided to go teach math in Japan or something.
Good.
Japan uses metric.
They do.
So what would the fuel economy be in Japan? And by that I mean I have miles per gallon. And what I want is kilometers per liter.
Okay.
Now this is a beefier problem, right? The miles has to turn into kilometers somehow, and the gallons has to turn into liters, and somehow fuel economy is just I'm gonna get a number, and okay.
We got it. We can do it.
So here are the things that I know. You Google, and then you look up that a mile is about 1.609 kilometers. Boom, you have that as your equation. You also look up that a gallon is about 3.79 liters, okay? So those 2 equations turn into 4 different conversion factors that we could choose from. And again, because this is a harder problem, I think it's so important just to write them out. You need them off to the side. You need them to stare at and be like, that's the one. Railroad tracks, 32 miles over 1 gallon. So you see how just for clarity, for my own clarity, I have that one that I've added to the bottom, right? And the miles is on top and the gallons is on bottom. And so what's going to happen is, first we are going to kill miles. So you see how I chose the 1.609 over 1? And that's because I wanted miles to be on the bottom so that the units would cancel.
Got it. Okay.
Finally, I need gallons to turn into liters.
Mm-hmm.
I need gallons to go away, which means I need a gallon, a GAL on
On
top,
top this time. Okay.
which implies I should use this.
Mhm.
And so that's what I think is so tricky about this problem. When you have a unit on the bottom that you're trying to convert away, it can make you dizzy.
Mhm.
So we know we're going to choose this one now because we had this all visualized on the paper. You choose 1 over 3.79. The units all cancel all pretty. You get your calculator going, and you get that it's about 13.585 kilometers per liter. Now, I have been learning from you,
Uh-huh.
and I've been learning about significant figures.
Uh-oh. Okay, here we go.
Okay. And what I Googled, and I hope I'm right,
Okay.
is that you look at your problem,
Mhm.
and you look at how many sig figs are given in the problem, which is 2.
Mhm.
And that is why when I was Googling the conversion factors, I got plenty of significant digits on my conversion factors, and then you answer with the lowest number.
Essentially.
I'm right.
Mhm.
I'm right.
You're right. The only caveat is that when it's addition and subtraction, you use different rules. So what you use are perfectly correct.
Because
for
everything
math
is multiplication and division.
Exactly. Yep.
Which means that if I were literally answering this problem on a test,
Mhm.
I would want to respond with
Boom!
14 kilometers
Yes,
per
you
liter.
would!
And so that, whatever that means, that's my fuel economy in Japan.